So in this video we're going to go ahead and calculate the magnitude or the length of a vector in component form. So the idea is if we have a vector with an initial point x1, y1 and a terminal point x2, y2, we can calculate the length of the vector or the magnitude of the vector, which is denoted using these vertical bars. These vertical bars means the size of v. We can calculate it by taking the sum of the squares of the differences between the x components, between the x component of the terminal point and the x component of the initial point, and the y component of the terminal point minus the y component of the initial point. And what we want to recognize is that this is just an application of the Pythagorean theorem. So remember from the previous video, we identified that we could construct a right triangle from our points x2, y2, and x1, y1. And if we do that, that means that x2 minus x1 is going to be the directed distance along the base of this triangle. It will be either positive or negative depending on which direction the vector is pointing in. So we know the length of it's always going to be at the absolute value of x2 minus x1, and the height of this triangle, right triangle, is going to be y2 minus y1, the difference between the two height coordinates that go with the right triangle. And that's going to be the case regardless whether our right triangle, regardless of which direction our vector is pointing in. So the distance across the base of this triangle, if we take x2 minus x1, we're going to get a negative number, but if we take the absolute value of it, we get the positive distance across the base of that triangle. And if we take the absolute value of y2 minus y1, we get the height of this right triangle as well. And then then we just apply the Pythagorean theorem. We know that the length of this vector, let's say we name this vector vector u, then the length of that vector, because this vector is, the length of this vector is just going to be the hypotenuse of a right triangle, we just apply the Pythagorean theorem. The square of the hypotenuse equals the sum of the squares of the legs of the right triangle, and we get the absolute value of x2 minus x1 plus absolute value of y2 minus y1. So it's just a Pythagorean theorem, and to get the actual length of the hypotenuse, you just take the square root of both sides. And what we want to recognize is, because we're squaring, the absolute value sign then becomes unnecessary, because when we square a negative, we're still just going to get a positive number. So we typically just drop the absolute value symbol off as being unneeded. So for example, if we want to calculate the length of the vector w, we would just take the square root of the sum of the squares of the legs of the right triangle that you can form from this vector. And that's just going to be your x2 minus x1, so 3 minus 8, plus your y2 minus y1. So we just get the square root of negative 5 squared plus negative 1 quantity squared, which is just going to be the square root of 26, which doesn't simplify because 26 is the product of two prime numbers. So the square root of 26 is already in simplified radical form. And the other thing that this means is, if we have a vector that's already in component form and we don't know what initial and terminal point was used to create it, we still know that these are the sign differences for the base and the height of a right triangle in the xy plane. So if we want to calculate the size of u and we already have it in component form, we just take the sum of the squares. We don't need the x2 minus x1, y2 minus y1. That looks like a 9 instead of a 4. And so we get the square root of 9 plus 16 is the square root of 25, which is 5 in simplified radical form.